Cheeseburger.
now.
Only 5.
Yeah.
Okay, so anyway, Charleston, South Carolina is an area that is risky. Well, you notice that Florida
We should be on the.
and Texas, Florida, Texas, and the states up north here don't have earthquakes. Actually, I think Florida and Texas are the ones that have never had an earthquake occur. Okay, this is the risk map. Okay, the damage map. Who's going to have an earthquake that's going to create damage between minor, moderate, and major? Again, it kind of coincides with the risk map. Charleston area, New Madrid. Notice Pennsylvania is really all in a minor damage area. None in Florida, Texas area. And of course, California and the Rockies kind of expected some major damage because of their geologic setting out there. Of course, the San Andreas Fault, the most famous fault maybe in the world, obviously in the United States. Continental plates, or actually a continental plate against the oceanic plate, going 2 different directions. Yeah, you're going to have friction and separation, and you do expect earthquakes along that region. Of course, the Richter scale is something that is commonly used when reporting an earthquake, and you'll see on this chart that there's basically very, very small earthquakes daily. Like every minute, we could have a magnitude 1, for example. And as the magnitude does increase, the population, as we call it, does increase. Like a magnitude 5, it might be every 10 years, sort of thing. And of course, we get to the 8s and 9s. They are kind of a rarity of not happening every year, but maybe not for every 100 years, might be stretching it, sort of thing. And by the way, there's no reason that we can't have a magnitude 12 earthquake. The scale doesn't stop at 10. Okay, that we could have magnitude 12 earthquake. It's never happened. The largest earthquake there that we recorded is a 9.2, which I believe was Sumatra back in the early 2000s. So there's P and S waves. When there's an earthquake that's created, P and S waves are created. Think about this like you throw a rock into the water, a pond, and you see those rings of water going out from the impact. The P waves are traveling pretty much in some type of a straight line. P waves do go through solids and liquids, gases, as it shows you on here. Okay. The black lines are the P waves. So P waves can actually, in essence, go, if you have an earthquake up here at the top, get my pointer again. P waves can actually go the whole way through the center of the earth and out the other side. Okay, and S waves cannot go through gas or liquids, so they are reflected off of that back onto the surface. And you also will see that P waves can actually go around the earth. I believe it was, again, the Sumatran earthquake in 2003, where the P waves went around the earth twice. The seismic stations picked that up. So what's important would be between the P and S waves is the fact that the P waves travel the fastest, so they arrive to a seismic station the quickest. So here on this graph, this seismogram, we have the arrival of the P wave right here. And then we have the arrival of the S wave. And the surface wave which is what we would feel if we were in an earthquake. We feel that what's called the surface waves are the slowest, and they'll arrive back here. But the arrival time interval between the arrival of P and the arrival of S, that interval time is how we calculate how far away from a station was that earthquake. In the old days, it had to be done by graph and figured out. Today, of course, with the computer age, the computer does that fairly quickly. So here's two seismograms that were actually recorded in Middletown, Pennsylvania at the Pennsylvania Geologic Survey. This is the January 12th, 2010 Haiti earthquake. You see the arrival of the different waves here. And the one on the right is the February 28th, 2010, one of the Chile earthquake. Of course, that was a much larger earthquake. And you can see that when you see a gram like this, that far away, it was a major earthquake. And actually, the P and S wave distortion kind of got obliterated basically right here. So if you were taking a geology course from me in college, I'd have you do an exercise where you'd have to figure out how far, how long or how far away an earthquake was by measuring the P and S wave. Time travel on the left-hand side in minutes, and along the bottom is kilometers, how far away, and you would know your interval, and slide your paper that you have your two marks on across the graph until they line up onto the P wave line and the S wave line, and that will give you the distance away. Basically, I said in the old days that's what we had to do. Today's technology with computers, they do that for you. All right, this is another map. This is the shaking. How much shaking is going to be from an earthquake? Again, yellow is low, red's very high. Again, Pennsylvania, you see we're kind of in mostly the low. It kind of corresponds to the risk map and the hazard map. And the eastern part has a medium probability. Again, Charleston showing up, New Madrid showing up, and we have this area in western. Actually, it's on eastern Tennessee. There's a seismic area there that's been kind of active of recent time. All right, Pennsylvania. All the dots on here represent the earthquakes in Pennsylvania from I believe it's 1950s on, and you'll see where the concentration is really occurring. Lancaster County, up in the Berks County, a couple in Lebanon, a few over in Lehigh, and over here north of Philadelphia. And out here in the western part of Pennsylvania, not to have you guys unknown, but we do have some activity in the northwestern part of Pennsylvania. In fact, the largest earthquake to have occurred in Pennsylvania, 1998, 5.3, was this one right there. I think they had to move the Pennsylvania line a little bit to the west to get it credited into Pennsylvania. The Pontotoning earthquake, that was called. And you see we have one in York County, which is Dillsburg. We'll be talking about Dillsburg here rather soon. So, but Lancaster County is like the king of earthquakes. And we're going to introduce to you what's called the Lancaster seismic zone. in just a little bit. Here's a newer map of Pennsylvania, created from our the recent network that's been installed across the whole state. Up until 8 years ago or so, we had a very poor coverage of Pennsylvania. We had seismic stations like at Penn State, Millersville, Lehigh University had a station, Lamont Doherty up in the Palisades in New York. They kind of monitored all the earthquakes in northeast Pennsylvania, northeastern United States. But here you get to see the coverage of where the larger earthquakes again. Again, you're seeing Lancaster County. Here's Dillsburg showing up right here, and over toward Brooks and Lehigh County in that area. Here's the Lancaster seismic zone. Okay, this is actually putting together the Lancaster earthquakes with the Berks County earthquakes, and there's a few theories out there about what's going on in this area. Some are, as all theories, some are good, some are bad. Why this area does have more earthquakes than other regions. So again, around the Lancaster area, particularly in southern Lancaster County, Lidditz again, and we work up towards Sinking Springs, which is on the west of Reading. Has been known for all this seismic activity. The geology is not all the same. This is the Triassic area rocks up here, the 200 million year old rocks, versus down here we have rocks that are 500 million years old. So it's not all the same geologic belt. It's just the geographic area where these earthquakes are occurring. So yeah, there could be something to it. There's more research to be done to really know for sure. Lancaster County, this is actually a page out of a report that a seismologist put together a number of years ago, showing you that there might be a cycle. Of course, the older ones are historically by either published in the paper. No recordings of those at all, because seismographs were not around until about 1910 or so. But you look at all of this, and they're pretty good up, from 1798 to 1834. Then there's a gap, 1865 to 1892, and then we take a break, and then in 1972, and we take a break after 86, and so forth and so on. So I'm looking for the 4.3 Easter Sunday one that we had April 22nd of 1984. Actually there, but the magnitude turned out to be 4.3. That was a larger. That's right. That's actually, here it is, 4.3 right here. That's right. That was on Easter Sunday, April 22nd, which is also Earth Day, which is kind of funny. All right, so more Lancaster County stuff. Landisville, Rothville, Millersville, Willow Street, if you know the area, Conestoga. These are 1984 to 2008, 2016. Again, not huge ones, but they obviously were felt, made the media. Another list of Lancaster County earthquakes. Conestoga again is a fairly hot area in the southern part of Lancaster County. And then we get around where the train museum is. 2000, they had a magnitude 2. Rothville, Reynolds, Landisville. Landisville, this is the one 95. I helped to investigate this one in 95, and the person who lived very close to what became the epicenter said she thought a plane crashed in her front yard. That was her reaction. All right, here's this is the one I'm talking about, actually. December 27th. The epicenter was right here, right across the street, basically from the Lancaster County Firemen's Training Center, near Salunga. A lot of times you can't really place a fault, what fault these were associated with, because our geological maps may not be accurate and not detailed enough. Berks County, okay, Sinking Springs area. This is the northern part of the Lancaster seismic belt. And again, Redding and Sinking Springs area, the state park with the big lake is right there, basically. Sinking Springs has had its number of small earthquakes. One earthquake, and I don't remember the year, was kind of proven to be caused by the dewatering of a limestone quarry in that area. They pumped the water out of a quarry, and with the less weight on the crust, the rock moved to like stretch, and it created an earthquake. So that was kind of an interesting thing. You've seen this map before if you've been with us a number of times, but all the pieces of the crust that are put together into southeast Pennsylvania, these things called terrains that were pieces of crust not forming on the North American continent, but they formed elsewhere, and they collided with North America over the millions of years. So the Potomac terrain, the Westminster terrain, we have this area through Lancaster, York County, the central part, with the limestone being on a continental shelf, and the Mesozoic basin. This is a rift valley in which Pangea was trying to break apart Arn, as Pangea was pulling apart, 200 and 170 million years ago. It did not pull apart. It was a false rift. But this area has become weakened because it was under stress at one time. So there's reason to have earthquakes in particularly the southeastern part of Pennsylvania. There's a fault called the Ramapo fault. Local geologists that study southeast Pennsylvania know it as the Boulder Fault, which is on the north side of the Mesozoic basin. There is the Ramapo Fault coming right down through here. That's mapped as the Boulder Fault, the border between the Mesozoic basin and the other rocks to the north and west of it. And this fault has been known to be active to where it starts up in New York, and actually it unofficially ends very close to Mechanicsburg here in Pennsylvania. Although can it go? Let me go back to the next slide. Can it go further down this way? Is still up for debate. Some geologists that have mapped this area say yes, the border fault is there, and some say no, I don't think it's there. But anyway, if you ever read about the Ramapo fault, it's also known as the Boulder Fault for the Mesozoic. I thought this was kind of good. Now, this is what I'm just talking about, the Mesozoic basin. We know it of the Gettysburg-Newark section. And the green area is that Rift Valley that was trying to pull apart. It has gotten weakened again by the stress of trying to pull apart that way. And this is where we're going to talk about Dillsburg, the earthquake swarm. It's the only one that had only location that had an earthquake swarm in PA. And actually, it may have started back in June of '97, where there were 3 earthquakes. Here's Dillsburg right there, but south of Dillsburg, in this area right here, someplace, was the 3 earthquakes, very small earthquakes, within 24 hours. We didn't get too much good seismic data from it because actually, when one of these earthquakes occurred, Dr. Scharnberger at Millersville was changing the paper on the seismograph. This is before the computer age, by the way. So he was changing the paper on the seismograph when we experienced one of those earthquakes. So we did not have any records of that at all. But just based on people's reactions that we did interviews, someplace in this area along Route 74 south of Dillsburg is where the epicenters were. So here's the geology of the Dillsburg area. The red is a rock that we have talked about a lot called diabase. I always refer to that as, the rock at Devil's Den, Little Round Top at the Gettysburg Battlefield. And the other rocks are sedimentary in origin mostly. Sandstone, shale, a little bit of limestone actually in here, which is what this blue is. And the shaded that I'm pointing out is a metamorphic rock called Hornfell, which is the sedimentary rock that got heated by the diabase and changed into a more dense rock. So that's the setting for the Dillsburg in 2008. We started to experience what we called the Dillsburg earthquake swarm. I've done a program on Dillsburg here in the Zoom Rock Room before. But October 5th, 2008 was the first one. And it was centered just about a mile east of Dillsburg, right there. I have this in here because the computer the next day did move the epicenter down here close to Wellsville. The United States Geological Survey's computer had some more information that wanted to move the epicenter from here down to here, but the following day on the 7th, the epicenter was back up here. So you had to be paying attention. But that was the first one of maybe 4,000 earthquakes that occurred. And usually to get good data, you need information from 4 seismic stations to come through for you. So here's one seismic station. This is the Millersville, Franklin Marshall College's Soldier Delight, Maryland, and SSPA is basically State College. All recorded the same earthquake. So you can get the PNS wave information off of these and come up with the magnitudes of the of that earthquake. From Millersville, this is with the Millersville seismograph, which is no longer active. This is actually one from move my box out of the way here. October 19th, 2008, like 2 weeks after they started. 2 earthquakes occurred. There was like a 15-second quiet time. 1.9 and a 2.1 showed up there. When Dr. Scharnberger first saw this record, he thought it was actually all one earthquake, maybe around a 3, but then he saw right there, if you look at it really, really close, there was actually 15 seconds of quiet time. So this is how Millersville was recording them. And you could go online and actually see them right away. We went up and we did interviews with people. We basically drove the neighborhoods, and if it's saw somebody usually out working in the yard, we stop and talk to them and say, well, last night at so-and-so, you had an earthquake. What did you feel? And then we would put their responses on a piece of paper, and based on what we call the modified Mercalli scale, which I'll show you in a second, we were able to zone it off. Number 4, area 4 is where they felt the most. So maybe the epicenter was in here. 3, not quite as much. 2, lesser. 1, yeah, maybe I felt something. I may have, I may not have. And then if you didn't feel anything, you didn't get a number. And that's important too. So we did this for the first couple because we had no seismographs in the area actually doing any recording. But Dr. Schauenberger, after we started to realize after 2 weeks' time that these earthquakes were continuing, Dr. Schauenberger contacted Lamont Doherty Observatory, a part of Columbia University, who are like the kingpins of seismology in the Northeast. And we talked them into bringing down three of their seismic stations, portable, solar powered, and we buried the sensors in the ground like that, and we got recordings. We had to come by and change the camera cords every few days and send them back up to Lamont Doherty. And this is kind of what one of the cards, this is what one of the earthquakes kind of looks like. These are 4 stations that we had set up. And this is all one of the same earthquake. So this earthquake occurred closest to the TIBE, Tibet station, because it's closest to the edge of the paper. And this is the P and the S waves showing up. So this is what the cards did for us, and you can load them into a computer, and the computer actually would plot it on a map like this of where the earthquakes were occurring. And this is Old York Road, if you know the area. Dillsburg, this is the Ore Bank Road that goes out to 15 if you go further north. And right along here is where it seems like most of the earthquakes were occurring in that region, okay? And we actually were able to do a graph of popularity of earthquakes between October 2008 and July 2009. And you can see, for example, here on this day in October, middle of October, we had close to 52 earthquakes in one day. So certainly we look for patterns, sort of thing. And these actually continued sometime into April 2010 is when they stopped. We don't know exactly when they stopped. It's somebody kind of recognized the fact that, hey, I haven't felt an earthquake for a while. So cable repairman man was on in my street and asked me what time it was. I told him it was between 8 a.m. and 1 p.m. And like Albert Einstein says, nothing happens until something moves, and that's how earthquakes do occur. So back to Dillsburg real quickly here. This is where these earthquakes were happening. It was pretty close to what's called the Dillsburg magnetite deposits, where they had iron mines working in the 1800s. And in 1949, the United States Bureau of Mines came in and actually drilled a number of cores looking for additional iron. Was there any more iron there that they could open up an iron mine after World War II if they needed to? And these were great records for us to look at the geology and how deep. So here's diabase, the limestone rock with the iron ore, black's the iron ore, is it wedged in between. But so we have a diabase intrusion on top, we have a diabase intrusion on the bottom, and the limestone and the ore are trapped in between. And so we had these cores to really get some real good coordination going on. And we knew how deep these things were happening. So these got plotted. And some of them were a quarter mile deep. Some were a half mile. And some were actually, a couple were down to about a mile deep. But look at the geology. The red's the diabase. The green's the limestone with the magnetite ore. And most of them were happening along borders. The contact between the iron ore and the diabase, or in the diabase, which makes sense because if limestone would be broken during an earthquake, you would never know it. Limestone is very soft; it would just crumble. Diabase is being as dense as it is. When it broke, it let everybody know. It actually exploded. Okay, so here's the iron mines I was speaking about. The majority of the earthquakes I showed you on the earlier map, right down in here. So one of the theories was that Dr. Schoenberg felt that we're getting pressure on our crust from the northeast in Pennsylvania, this part of Pennsylvania. Pressure's coming from the northeast, and the rocks around Dillsburg area just got enough pressure that they had to relieve themselves, basically, and produce this earthquake swarm. Swarm is a cluster of earthquakes that don't have a major event. They're all pretty small. They show up mysteriously and they'll disappear as mysteriously. Sometime, a month, two, or in this case, it was like a year and a half. My leading theory I like is groundwater mining. All these houses, which were actually sitting where the epicenters were occurring, have wells. And at that point in time, 2008, these houses were about 10 to 11 years old. So I think what was going on is that they were taking the groundwater out for their use and taking pressure off the crust again. And Mother Earth was able to stretch again. And that's what was creating the earthquake swarm. That's my opinion. That's what I like the best. So through that, I tried to talk to the local Dairy Queen on Route 15 to produce the milkshake, the Dillsburg shake. They never did it. They made me one with chocolate, vanilla, and strawberry ice cream, but they would not put it on the list. So anyway, all right. Other earthquakes in Pennsylvania that are notorious besides the Pontotoning. This is in 2019, not too many years ago, June the 12th, 2019. There was an earthquake, 3.4, out here north of Saulville, west of Newport, Juniata County, Snyder County, I believe, border. Interesting earthquake, for the Appalachians. Earthquakes don't happen often within the Appalachian Mountains. And what made this one really interesting was that the depth. Most Pennsylvania earthquakes will be rated at a mile to 3 miles deep. But this one is 16.8 miles deep after all the research was done. That's incredibly deep for Pennsylvania and for the Appalachians. It's very possible the 16.8 miles is the depth to where the Appalachian rocks are sitting on top of what we call basement rock, the old rock, maybe like granite. That's the building block for our continent. Although the seismic maps for the basement rock for that area show it to be some 20 miles deep. So that was a very interesting earthquake that did occur because of the depth. And this is actually the responses from people. You can actually go online if you feel an earthquake. You can go to the National Earthquake Information Center of the USGS, find the earthquake that you felt, and then enter your zip code. And so these are all the responses that came back from that earthquake. They felt the whole way down the south of Hagerstown, out to Altoona, north of State College, and even into southeastern Pennsylvania, even around Lancaster, Lebanon. People reported it, York. So this saves us going out and doing interviews these days with this newer technology. So one here in York County that happened September the 14th, 2019, only a few months after the Appalachian Mountain one, 2.9 as a Saturday night. So I was actually home from the racetrack that night because my wife had just gotten home from a cruise. And York Airport is laying about right in here. So Route 30 at Abbottstown. So in this area right here is where the epicenter was. Never really could place it very well. But it happened within that Mesozoic basin again. 2.9, that's kind of a sizable earthquake for the Mesozoic era. And again, here's the USGS graph of who felt it. We felt it here. We're about 6 miles the crow flies from that point. So I actually did feel it and knew what it was right away. Waited for the internet to light up. So again, you can go onto the United States Earthquake Information Center website and find that earthquake. As I was saying earlier, number of events versus the depths. Majority of the earthquakes in Pennsylvania are 1 to 3 miles deep. Most of them. So very few are. This is 10 kilometers, 20 kilometers there. Okay, we do have, as I said earlier, the Pennsylvania State Seismic Network. You may want to put this into your favorites, onto your phone, into your computer, because it will cough out earthquake information when there is one. And what they have managed to do is that they've marched across the state from west to east, planting seismographs into permanent stations. Franklin Marshall here, okay. All have these stations. So if we have any seismic events, at least 3 stations will probably pick them up and send them back to the motherboard at SSPA at State College. So they do have a website that you can actually go and look at the real-time earthquakes. And they do have it divided up between natural earthquakes and man-made earthquakes. Why man-made? Well, because we know that blasting at a quarry, for example, a large blast at a quarry, can produce P and S waves. But there's a way to see on a graph if they are natural or man-made earthquakes. So the network actually has them ranked out. There has not been a natural earthquake in Pennsylvania for several years now. The Lehigh University Earth Observatory, I don't think their live network is up anymore, but they have some cool information on their website about earthquakes in Pennsylvania of recent times between the Mercalli scale, which is the one I was showing you with Dillsburg, with the people telling us about what they did feel compared to the Richter scale, and get to a very famous earthquake. It did not happen in Pennsylvania, but it was felt in Pennsylvania. Was the famous Mineral, Virginia earthquake, which I think it happened in it happened in 2011. I always forget what year that was. But Mineral, Virginia was right here, and you'll see that people felt it. Actually, they felt it as far north as into New England. It was a very extensive earthquake of, say, 5.9, 5.8 on the Richter scale, 6 miles deep. So this is actually in the same geologic belt as Dillsburg in the Mesozoic. But a lot of you folks probably remember that, feeling it. So a lot of property damage in Mineral, Virginia. The National Cathedral in Washington, D.C. was had damage to the steeples. Dover, Delaware. Here's one from Dover, Delaware. That happened under the coastal plain, which is somewhat sometimes an active area. Maybe where the coastal plain sand is resting on top of a bedrock, if you want to call it that. That shows some movement. So that was a 4.4, 2017. And this is of interest. Large earthquakes we know can cause the groundwater to swish back and forth. So this is actually a well graph of a well down in Virginia. Oh, I'm sorry, West Virginia, McDowell. And you can see that earthquake, this one happened in Mexico actually swished the water to have it rise higher in the well until it settled back down. So big earthquakes can actually affect your water table. Okay, so interesting fact is that we've had 34 earthquakes in Pennsylvania since 2014. That number's pretty high for the history of Pennsylvania earthquakes. I don't have an answer. I'm not a seismologist, and there's not really an answer. It's just kind of something to be alerted to. So, according to Dr. Charles Schoenberger, he likes probability. There's a 60% probability of a 6.0 earthquake in our area in the next 200 years. So just think about that. There's a 60% probability of a 6.0 earthquake in our area in the next 200 years. Another sense of humor. I'm real quickly going to discuss this. East Coast earthquakes versus West Coast earthquakes. East Coast, we have a lot of bedrock, obviously. That's where a geologist sleeps. If you've never heard my that joke before, okay. And we have bedrock. So when we have earthquakes happen on the East Coast, the bedrock actually transmits the waves very well. Certain rocks transmit the waves better, but bedrock in general is a great transmitter of seismic waves, the P wave, the S wave, the surface wave, and they can go long distances, just like the Mineral Virginia earthquake went into New England. Okay, out in the West Coast, they have unconsolidated sand laying on very, very deep sands, followed by bedrock. So the unconsolidated sands do not, because they're loose, they're not glued together, not one substance. They cannot transmit the waves as well. So 4.0 earthquake in the east is going to be felt over a wider range area than the West Coast. I'm going to skip through this kind of quickly, watching my time. Fracking and earthquakes. Since fracking has been introduced in our country, in Colorado, Louisiana, Ohio, we've known that fracking does cause earthquakes. And that's a known fact. I know Colorado proved it. They actually had fracking going on, and they had earthquakes. The state asked the fracking company to shut down for a bit, and the earthquake stopped. And they started back up fracking again, and the earthquake started back up. Okay, so with our Marcellus shale wells, which are the ones in red, that's where they're taking the Marcellus shale out of. And the other shale wells, other oil wells are in the blue. If you watch the Pennsylvania State Seismic Network map for the man-made earthquakes, you'll see that all those earthquakes that are man-made pop up in this belt that I'm pointing right there too. Okay, here's the fracking earthquakes. Up in this area, up in here. So I said the Appalachians do not have many natural earthquakes occurring. All right, one last thing I want to make you aware of. There's a thing called an ice quake, a frost quake, a cryocism quake. These occur in the early winter time when we have a warm spell. We might have a lot of rainfall, might have 2 or 3 inches of rain, saturates the soil, and the next day it's like 25 degrees. It freezes the water, and of course, when water freezes, it expands, and it literally puts off a little explosion sound. So you see it is caused by a sudden cracking action in frozen soil. That is saturated, and that's an important word, saturated. So these were not known in Pennsylvania until about 12 years ago. They were well known up in the New England states and Wisconsin, Michigan, where it's pretty cold in the wintertime, but not in Pennsylvania until people started to report these things, and I started to pay attention to them. And so this is just kind of a diagram here. Temperature falls rapidly, causes the water to freeze. The new underground ice expands, putting stress on the soil and bedrock. Stress builds until the rock or soil cracks, and a loud boom. Now that loud boom could only be heard maybe by 3 neighbors. It's not a regional thing. It's very, very localized. But they can happen multiple places. One night here in York County, there's one night in York County when these were happening, I had 4 or 5 neighborhoods that heard the booms, but they didn't hear all the same boom. So this is what could happen. I have never seen a crack in the soil, I guess. The larger ones do create. I've actually have seen cracks in ice that were probably by a frost quake. But they only will occur that one time. Warm to cold. And then you don't hear of them the rest of the winter. So here's where frost quakes are commonly found. And you see Pennsylvania, we're not red. We should be red now. Oh, we are red now. So anyway, I have a database of when these were recorded. I need to update that for 21. I don't think we had any in 22. The weather just wasn't quite suitable for that transition to occur. 21, I think we did have very commonly around Thanksgiving, although the 2020 was late because we had a very warm November, December. I remember that now. So around Thanksgiving, I'm always waiting to hear somebody's going to post on Facebook. Anybody hear that boom? I knew what that was. So anyway, this is picked up by a seismogram at the Pennsylvania Geologic Survey of a possible frost quake. It doesn't create any PNS waves. It's just vibrates the ground enough, and in this case, it may have picked up. We've not confirmed that this was a frost quake, but it was a suspicious recording that the survey found for me around the time that some people in Dillsburg were reporting these frost quakes. So that's what you hear, a faint boom. I've heard them here at the house. I might have a little house shake, and very, very, very localized. So the last joke of the night, getting a little tired, had a real blast, and we're going to get back to you right now. If anybody has any questions, put my reading, since I don't have Melanie here tonight.
I got one for you, Jerry.
Yep.
It's not a question so much, just a little quick story. This involves the Mineral Virginia earthquake.
Okay.
I was at a training in the computer lab at the Topo Geo office in Middletown that day. And we were in the middle of the session when we felt it, thought it was just trucks on the highway because that's right next to main artery there. And suddenly we heard all this hooping and hollering and shouting, and all these geologists started running out to the lobby to check the seismograph. And then suddenly we heard this big sigh because they forgot that the seismograph had been broken and it hadn't got it repaired yet.
Oh,
So they weren't able to record it. You never saw a bunch of sad sack geologists as that day.
oh my. I see a question here. What's the Jonestown volcanics? That's in the Mesozoic basin. And it actually was they were volcanoes during the Mesozoic. I talked about diabase. Diabase is a igneous rock that formed as an intrusive rock inside the ground. It was not lava, but there are only several places in Pennsylvania where within the Mesozoic basin there were volcanic extrusions, and Jonestown Volcanics is one of those over in Lebanon County. There's one in Adams County near Aspers, very, very small basaltic flow. Yeah, there is gold around the Mineral Virginia area. Loud booms are reported on next door West Hanover throughout the year. Yeah. I think you kind of keep me apprised of that. Why Tennessee for ice quakes? I'm thinking that's because of the mountains, the Blue Ridge Mountains. I'm sure they're not happening in Nashville, Memphis area at all, sort of thing. So I actually had what time is it? 8:11. I actually had a newspaper, and then I had a TV interview one year about these frost quakes when they occurred. Fox 43 got a hold of me and they wanted to do an interview. So I told them where to meet me, and then we'll do an interview. Well, they didn't tell me beforehand that they had gone to Millersville University and they talked to a professor over there about these frost quakes. And he said, frost quakes don't happen here. What they heard was a tree limb hitting the ground. But the reporter didn't tell me that until after I was done, which is probably good. but yeah, and I've convinced Dr. Schomburger, who some of you will remember, he's been on the Zoom Rock Room early in this when we started this in 2020. But he didn't believe me at first about these frost quakes, and he started to see reports in the mail in the newspaper, particularly out in what county is that? Altoona area, Blair County. He saw this one newspaper report about Blair County hearing these booms and stuff, and I think he's convinced now that we do have frost quakes. So anyway, thank you, Paul, for that story. Anybody else have a story or a question?
Well, I saw Franklin County wasn't on the list,
Oh.
but about 20 years ago, we heard booms. I thought sure that somebody had hit my siding with a baseball, but we never found any any trace of what had happened. And then people weren't speculating on Facebook so much, but people were saying, oh, well, maybe it was construction, maybe it was this, maybe it was that. But now hearing about this, I'll bet that's what it was.
He actually close to where Melanie Anderson Smith lives. When did you have that earthquake, Melanie? The last one out there. You remember? You're muted. Sorry.
Yeah, I do remember feeling it. I don't remember the year, but I was at work.
That was
and
only
we had it
that was
at
only
Renfrew. Yeah,
that was only about 5 or 6 years ago.
yeah, that was before I retired. So I remember being in the barn at Renfrew and feeling the shake.
Yeah. So these rare ones kind of do happen. And we just like Dillsburg after 4,000 earthquakes, that we still don't know for sure why. That's part of the science. 2011 Mineral, Virginia earthquake. We were actually heading to Bristol NASCAR. Or that it was a Thursday, and I got down. We were down around Roanoke, I think, Virginia, and a couple of my friends from York called me and said about that they just felt something, and I started to feel like, oh gosh, I'm gonna be away all weekend from all this excitement. And then a friend of mine that reports at the York Daily Record that has followed my earthquake career around, she called me and I said, where was this located? And she said, Mineral, Virginia. So it took the pressure off me, like, oh, that's outside of my area, but then I had a phone call from Fox 43. Can we come talk to you about the earthquake? I said, if you want to come to Bristol, Virginia, help yourself. I'll be happy to talk to you. Okay, so we felt
Yeah,
that.
what Greg just noted there about Franklin County, where we live, we're not far from Letterkenny, and there are a lot of booms.
Yes, yeah, that's true. Yeah, that's true. Again, we should be able to tell man-made or natural.
Mhm.
Caused by my neighbors. Yeah. The biggest and I say, how do I put this? I wasn't practicing for this one. The biggest result of hearing a boom, non-earthquake wise, is now a thing called tannerite. Anybody ever know what tannerite is? It's a
Detonation.
shooting targets, right? Aren't they targets that are made out of a material? If you stack them and you shoot them, it puts out a big boom, and actually sometimes a lot of smoke. And I've competed against tannerite. People have told me that they heard a boom, and I've gone out, or I've talked to neighbors, and they told me, my neighbor was shooting tannerite targets, but
We built a big snowman once,
oh yeah,
and after we built the snowman, we put a tannerite in it.
oh, okay, so yeah, that just kind of reminded me. Thank you, Joseph, for that. But that just kind of reminded me about tannerite being a competitor. So anyway, check out the Pennsylvania State Seismic Network and make it one of your favorites, because you never know when there's going to be an earthquake pop up that's natural. And just pay attention to the man-made ones. It's kind of neat, that sort of thing. So without further ado, I'm going to let you get outside if you want to see the rocket launch. It's 8:17 now, so you got 16 minutes. But thanks for joining us tonight. Melanie and I will be back September 5th. Watch for a couple special emails coming your way with some announcements in between now and then. And as always, we appreciate your attendance, seeing all your faces, happy faces. And everybody stay safe till we see you next time. Good night, everybody.